Welcome to Chapter 7, Unit 1, about zero and negative exponents. You should have the notes packet in front of you, and everything that I write down you'll write, and you'll pause the video at certain points in time to try and do things on your own. Please take a look. We're going to start our study of exponents with an exploration activity. If you take a look at the chart, I'd like you to pause the video and see if you can fill in the answers without a calculator. So pause the video and check your answers with what I have written down. 2 to the 4th, we know that is 2 times 2 times 2 times 2. The answer is 16. 2 to the 3rd would just be 1 less 2, so that's 8. 2 squared, we probably all know, is 4, and 2 to the first power is 2. Now here's where you might not know your zero exponent rules, so I'm going to see if I can follow the pattern, and each time I'm going down I'm dividing by 2. So if I follow that same pattern, that would mean 2 to the 0 would be 2 divided by 2, or 1. And then if I don't know my rules for negative exponents, I can follow the same rule, and 1 divided by 2 simply gives me a half. And 1 half divided by 2, or 1 over 2 to the 2nd, gives me 2 to the negative 2 equals 1/4. And those are the patterns I'm going to follow with my tens, except tens have a special rule. I know that 10 to the 4th is a 1 with 4 zeros after it, so that would be 10,000. 10 to the 3rd is 1,000, following that same rule with the zeros. 10 squared is 100, and that one's 10 times 10. 10 to the 1st, any number to the first power is equal to itself. And then following the pattern of the zeros, 10 to the 0 power is a 1 with 0 zeros after it, so just 1. And then 10 to the negative 1, that's where I kind of want to look at my patterns here. 10 to the negative 1, each successive term is being divided by 10, so I would take that and put it in the denominator, 1 divided by 10. And then here's 1 divided by 10 squared, or 1 divided by 100. So to answer the questions, how does the value of the exponential expression change when you decrease the exponent by 1? I would say you divide by, well, here I'm dividing by 2, and here I'm dividing by 10. We call that number the base. Divide by the base. And what do you think the value of 5 to the negative 2nd is if I were to write it as a fraction? And here you can pause if you don't want to just be told the answer. But following the patterns here, I'm going to put 1 over 5 to the 2nd power, and I get 1 over 5 times 5, which is 25. So using these patterns, we want to go ahead and see if we can explain the zero exponent property. So for every, and this is in math speak, for every non-zero number a to the 0 equals 1. Any 0 power number is going to be 1. So as an example, 4 to the 0 is going to be 1. If I take a negative number to the 0, also 1. And if I take a decimal to the 0 power, also 1. My negative exponent property is going to, so you've seen some number examples. Now my negative exponent property, I'm going to give a generalized statement for every non-zero number a to the negative n, so a to any negative exponent, you simply take the reciprocal, you put it in, when I say take the reciprocal, if it's in a numerator, you put it in a denominator. If it's in a denominator, you can put it in the numerator. So 7 to the negative third, I would take my 7, and once I've moved it to the denominator or taken the reciprocal, now it's not a negative exponent anymore. So I can just do 7 times 7 times 7 and get 343. And if I have a negative number to a negative power, I'm still going to take that negative number in my denominator, but now my power is positive. And negative 6 squared, which is negative 6 times negative 6, turns out to be a positive. So for my teacher-led examples, we're going to do a couple. And if you feel like you already know how to do these, you can pause the video and just check your answers. So 9 to the negative second, I'm going to take 1 over 9 squared, which is 1 over 81. And then I've got my zero power property. Anything to the 0 power is always 1. And here, now it's your turn. We call these the try it problems in my classroom. And so here is where you're supposed to pause the video and try on your own. I'm going to go ahead and work these out. 1 over 4 to the third gives me 1/64. And negative 5 to the 0, those are easy. Anything to the 0 power is equal to 1. So moving on to the back side of the page, we've got a few more try it problems. So let's check those out. 1 over 3 squared is 1/9. 1 over 6 to the first power, or just 1 over 6. And here we have a negative, so I'm going to keep my negative sign for my number, and I moved it to the denominator, so now it's being squared, and negative 4 times negative 4 is a positive 16. So if I have some expressions here that I want to simplify, that simply means when we simplify exponentials, we have a rule for exponents, and that is that you can never never leave a negative exponent. And the other thing for simplifying, we really want to have no negative exponents and no parentheses either. So these don't have parentheses, but later we'll see some with parentheses. So my 5a cubed, there's nothing I can plug in for a or b, but this negative 2 exponent has to be dealt with. So I am simply going to leave my 5a to the third where it is, and I remember my negative exponent property. I can move that b to the denominator and change the power to b squared. So that's what a negative exponent does. And here's where we were talking about the meaning of the reciprocal. 1 over x to the negative fifth. If it's in a numerator, like my b over here, then I would move it to the denominator. But if it starts out in a denominator, the reciprocal actually means that I would move it to the numerator. So that's my final answer for that one. So under now it's your turn. This is your chance to try some of these exponentials. Please pause the video and work problems A through E. And then I'm going to reveal the answers and you can check yourself. So if you don't want to have the answers yet, go ahead and pause the video. And now let's reveal the solutions. So here my exponent rule gives me 1 over x to the 9th. And here I've got to move it to the numerator, so n to the third would be my result. In letter C, my 4 is okay. My b doesn't have any negative exponents, but my c does, so I'm going to move it to the denominator. And in letter D, my a is in a denominator with a negative exponent, so I'm going to move it up to the numerator to live with this 2 here. And so I'm calling that the numerator because remember, all whole numbers could have a 1 underneath them, and that's really my denominator, but we don't have to write the 1. And last but not least, if in letter E I need to move my n to the negative 5 down to the denominator. My m squared doesn't have a negative exponent. It just has to stay where it is. So when everything is moved away from either the numerator or the denominator, we can have a 1 to hold its place. So if you'd like to pause the video and write a summary of the things you've learned in this section, and I'll write my own. I learned the zero power property and the rules of negative exponents. Thanks for listening.